In this video, I'm going to show you how I made this incredibly simple Scara Robotic arm. As you can see, it's mostly 3D printed and the rest of the components are really cheap and readily available from China. I believe that the entire arm only cost about $80 US. If you want to make it yourself, I'll have a link in the description to all of the 3D printed files so you can download them and print them yourself. Thanks for the feedback on my last video. I know the Z stepper is incredibly loud. I think it's just a bad stepper. It's always missed steps and made noise. So I've ordered a replacement and I'm gonna see if that fixes it. If not, then it's probably the electronics, because I'm using a incredibly cheap Arduino CNC shield. It's the cheapest one I could find. These chips, these stepper drivers, I believe that they are the A4988s. They are absolutely the cheapest ones out there, and you know, you get what you pay for. It's always going to be kind of loud, so if I were to build this again, I would probably replace them and buy some more expensive chips. I've also been playing around with the code. I'm using Universal G-Code Center to control the arm, and I've been playing around with the feed rate of the Z-axis to see if that reduces noise, and it did work. I got it a lot quieter, as you'll see at the end of the video, but it's still, you know, it's still kind of loud. But you know, I'm just going to show you how I made this in this video. Enjoy. So we start out with a nice solid wooden base. This is just some scrap wood I had laying around, and I'm going to use it to attach the Z-axis to. For the Z-axis I use 2020 extrusion, so I'll cut that to size now. Just gonna mount some L brackets to the 2020 extrusion, but the bolts I had were slightly too big, so I'm just going to use 3 washers to take up the slack, and that worked pretty well. So yeah, it's kind of tricky to line the L brackets up, but once I get them relatively flat, we're just going to tighten them up and then mount the Z-axis to the wooden board. So now I'm just going to mount the Z-axis stepper. It's just a very simple 3D printed bracket. So yeah, let's mount that now. So these are the Z-axis support mounts. I'm going to need to make 2 of these, one for the bottom and one for the top. They're going to support 2 8mm stainless steel rods for the linear bearings, and the center one is going to support the 8mm lead screw to move the Z-axis up and down. Next, I'm just going to mount the Z-axis supports to the Z-axis. So this is the first joint connector piece. It's going to connect the Z-axis to the first joint. It's also going to house the stepper motor for the first joint. I'm going to mount the 2 linear bearings onto it, and in the center I'm going to mount a captive brass nut that will allow the lead screw to move the Z-axis up and down. So this is the second arm where I'm going to mount the end effector on. But I made a mistake. I printed the part without tolerances, so the bolts were a really tight fit, and as you can see I had to hammer them in. Also, the bolts that I ordered were again way too long, so I had to use some spaces later on, as you'll see. So these are the first and the second arm. I'm going to connect these together, but first I'm going to mount a belt reduction gear. It's a 3-to-1 gear reduction ratio, so the big gear has 60 teeth, the small gear has 20. Then I'm going to use these bearings called thrust bearings to connect the two arms together. I'm using one thrust bearing on the top, one on the bottom, and then I tighten them down using the bolt, and this creates a very rigid connection, and I'm very happy with that. But as you can see, I ordered the wrong bolts, they're way too long, so I had to use a spare gear as a spacer. But it works fine, connection is very rigid. Then I'm going to mount the stepper motor, and I use the entire stepper motor to tighten the belt. So you just mount the belt and then pull the stepper motor backwards and tighten it down to tighten the belts, and it works very well. The belt hasn't slipped, quite the opposite actually. The belt was a little bit too tight in one of the first videos I uploaded. So yeah, I'm going to connect these together, and then later I'm going to also connect the first arm to the Z-axis in a very similar fashion. And this is the robot fully assembled and working. As an end effector, I'm using a very cheap suction cup from China and a vacuum pump to move this little flyer around. And yes, there are some improvements I still could make. I know the Z-axis is still kind of loud, but everything works and I'm really happy about it. I haven't really gone into the electronics in this video, so if you're interested, please let me know in the comments down below. I might make another video about that, so don't forget to subscribe, and thanks for watching.